Okay, 7.5. Factoring x squared plus bx plus c. So as promised, now we are going to be given a trinomial, and I'm going to ask, where did this trinomial come from? What product of two binomials gave me this? Some things to look out for here. Notice, this will work a lot of times when the coefficient in front of the x squared is a 1, which it is in this case. And then we're going to have some middle term and some constant here at the end. I'm going to put some letters with it. To factor x squared plus bx plus c, you need to find P and Q such that, that's an ampersand, P and Q such that P plus Q is equal to B and P times Q is equal to C. And I'm going to start with this right here. If I FOIL this out, x times x is x squared. X times q plus qx. P times x plus px plus p times q, which is just pq. What I want us to notice here is that this last term here comes from the multiplication of those two. The middle term is the sum of these. It is that x times the q plus the p times the x. That's that. When we are factoring, we are going to be look for numbers that when multiplied together give me what that middle term is. So in other words, what multiplies to be c then adds together to be b. So we're going to have to use factors of whatever the c value is, meaning what two numbers are multiplied together that will give me c, but then when I add them together, I get that sum, it gives me b. Here's how we do it. Factor. Here's an example. X squared plus 10x plus 16. I have a trinomial. It is going to factor into the product of two binomials, and what I know right away is that my two binomials are going to look like this. Because x times x is x squared, that gives me my first term. I am looking for factors of 16, what numbers that when multiplied together give me 16, but when I add them I get 10. You have to be systematic in how you go through and do this. Consider all factors of 16. I have 1 and 16. Start low, go high. 1 times 16 is 16, but 1 plus 16 is 10. That one doesn't work. Next one I can think of is 2, because 16 is even, it's definitely divisible by 2. 2 and 8. Now 2 times 8 is 16, and 2 plus 8 gives me 10. This is what I need to use. Those are the factors of 16 I need. X plus 2 times x plus 8. And I could have certainly switched this 8 and the 2, and it's not going to make one bit of difference, because it's all addition. You could check it by FOILing it back out. X times x is x squared. I have 8x plus 2x is 10x, and then 2 times 8 is 16. X squared plus 9x plus 8. It's all addition in here, so I know my binomials are going to be all addition. This is going to be x plus something, x plus something. I know that because these signs are all positive. Factors of 8 that when added together give me 9. 1 and 8. 1 times 8 is 8. 1 plus 8 is 9. I would also have 2 and 4, but 2 and 4 doesn't work because 2 times 4 is 8, but 2 plus 4 is only 6. That's what I need. X plus 1 times x plus 8. And it's factored. And you can certainly FOIL that back out, double distribute, whatever you call it, and you will get that trinomial. X squared plus 7x plus 6. Write this one out. B squared plus 18b plus 80. And let's do this last one. Y squared plus 20y plus 75. Go ahead and get those down. Pause the video and see what you come up with. All right. So again, these are all addition on this one. We're going to switch this up in the next section where maybe one of these is negative, maybe both could be negative. These are all positive, so I know it is going to be something like this. X plus, factors of 6 that when added together give me 7. Well, the only factors of 6 are 1 and 6 and 2 and 3. 1 plus 6 gives me 7, 2 plus 3 gives me 5. Has to be 1 and 6, x plus 1 times x plus 6. And again, you could certainly FOIL that out. X squared. Then I have 6x plus a 1x, 7x. 1 times 6 is 6. 80. Lots of factors of 80. 1 and 80. And notice, 80 plus 1, that's not going to give me 18. These have got to be way closer together than 1 and 80. Way closer than 2 and 40. 8 is not divisible by 3, so it's not 3. 4 and 20, that sum gives me 24. I know it's divisible by 5 because it ends in 0. 5 times 16 gives me 80. But 5 plus 6 is 21. I'm getting closer to that sum of 18 because now I'm at 20. I was at 24. Now I'm at 21. It doesn't go in there 6 times, doesn't go in 7, 8 and 10. 8 plus 10 is 18, and I got it. B plus 8 times B plus 10. And of course you could have B plus 10 first times B plus 8. But notice, I went through almost all of these factors of 80. Y squared plus 20y plus 75. Factors of 75 that add to be 20. Y plus some number, y plus some number. Factors of 75, 1 and 75. It's not even, it's not divisible by 2, 3, and 25. 3 times 25 is 75. 3 plus 25 is 28. I'm getting closer. It's not divisible by 4. It's divisible by 5 because it ends in 5. 5 and 15. And again, if you don't know your factors, just be systematic and use your calculator and get them and write them down. 5 plus 15 is 20. Y plus 5. Y plus 15, and I got it. Nice and straightforward on those. Notice, these were all addition. All my signs in my trinomial were addition. Now we are going to factor what happens when that middle term is negative, but my C term is positive. So I'm going to say B is negative and C is positive. And I want us to think about that for a second. Remember, this is the product of these two outside terms, that C value. And when this is positive, the only way for a product to be positive is if both of my factors are positive or both are negative, because a negative times a negative is going to give me a positive. So when I see a positive C value in a trinomial, and the middle value is negative, my signs will be the same, but they ain't going to be positive. They're going to be negative, because the sum of two negative numbers gives me a negative, but the product of two negative factors gives me positive. So if I'm presented with something like this, x squared minus 8x plus 12, the first thing I am looking for is right here, the C value. It's positive, but my B value is negative. That means that both signs of my binomial have to be negative. They can't be one positive and one negative, because this would give me a negative C value. A positive times a negative would be a negative. They can't be both positive because my middle term here is negative. And if you add two positive numbers together, it's not going to give you a negative. The logic is still the same. Because this is a sum, it's going to be a negative sum. You're still looking for factors of 12 that when added together give you a sum of 8. Yes, it's going to be negative this time, but I know it's going to be an 8. 1 and 12 gives me 13. 3 and 4 gives me 12, but then that's 7. But if I use 2 and 6, they're both negative. Negative times a negative is a positive. Negative 2 plus a negative 6 is a negative 8. This is x minus 2 and x minus 6, and you could certainly switch the order of these. Next one. X squared minus 14x plus 24. Here's the trinomial. Again, I'm going to look at it. I'm going to look at some signs in here. My C is positive, but my B is negative, and I know that both of these binomials have to be subtraction, because the only way to get a positive C value is if both are positive and both are negative, but I look to my B value to determine what the signs are. Factors of 24 that add to be 14. I got 1 in 24, that's too big. 2 in 12 gives me 14. X minus 2, x minus 12. You could certainly FOIL it back out. Negative 2 times negative 12, positive 24. Negative 2 plus negative 12, negative 14. X squared minus 12x plus 27. Go ahead and pause, give yourself a second, see if you can get it. I can certainly make my binomial right now because I know they are both negative, because that's positive and my B is negative. Factors of 27 that add to give 12, well, 1 in 27, no, it's not even, it's not divisible by 2. 3 times 9 is 27, 3 plus 9 is 12, they're both negatives. X minus 3 times x minus 9, or you could have x minus 9 times x minus 3. And then probably the trickiest one, which just takes a little more thought, you are going to have x squared. Your coefficient is still going to be a 1. You're going to have plus bx plus c, but I'm going to say this time, but c is negative. So now this is going to be subtract something here. This is going to be a negative right here. And when this c is negative, one of your binomials is going to be plus something, one is going to be minus something, because the only way to get a negative c value as a product is if one of my factors is positive and one is negative. Now I got to think a little bit though. X squared plus 4x minus 21. And again, I look at this and I'm thinking right away, that's negative. It's going to be x plus something times x minus something. Now order is absolutely going to matter because this middle term comes from the sum of the two factors. I still am going to think of factors of 21, but now I'm going to think of a difference of 4, not a sum, because one is positive, one is going to be negative. You're going to look for the difference of those. So if I have 1 and 21, the difference is 20, that's too big. But I have 3 and 7, that has a difference of 4. Now it absolutely matters where the 7 and the 3 goes. Because this middle term is positive, this has to be a positive 7, and that has to be a negative 3. Because 7 subtract 3 is a positive 4. Now if that was negative 4, this would be a positive 3, that would be a negative 7. So order is going to matter. I want my 7 to be positive, so this has to be x plus 7, and this has to be x minus 3. And you can certainly write it as x minus 3 times x plus 7, but what I can't have is x minus 7 times x plus 3. That gives me negative 21, but negative 7 plus a positive 3 is a negative 4. That's why it matters where the sign goes. That is what it is factored. Y squared plus 13y subtract 30. C is negative. That tells me something. It is going to be y plus something times y minus something. Factors of 30 with a difference of 13. Well, 1 and 30, that's way too big. 2, it's even. 2 and 15, the difference of 2 and 15 is 13. That's what I want to use. 15 needs to be positive. 2 needs to be negative. And notice, whatever the sign is here, your bigger number, your larger number is going to take on that sign. That's a positive 15. Minus 2 would give me positive 13. And negative 2 times 15 is negative 30. This is y plus 15 times y subtract 2. X squared minus 5x minus 6. X squared minus x minus 42. And I will give you one more here. X squared plus 2x minus 15. So we'll get those down, pause the video, give them a whirl, and we'll come back together. All right, again, C is negative. X plus something, X minus something. Factors of 6 with a difference of 5, 1 and 6. And I always get the answer of 2 and 3 on this one. 2 and 3 would work if this was positive. 2 and 3 would work if all of these were positive. 2 and 3 does not work because the difference of 3 and 2 is 1. It's not 6. I need 6 and 1. that 6 has to be negative, because negative 6 plus 1 is negative 5. 1 times negative 6 is negative 6. Looking again. Both are negative. I don't really care the middle's negative right now. What I care is that C is negative, so I know it's going to be x plus something and x minus something. Factors of 42 with a difference of 1. If you've got a difference of 1, hopefully you're thinking right now, hey, these factors of 42 have to be close together, and 6 and 7 pops into my head right away. And if that is negative 7 plus 6, that will give me a negative 1, so it has to be negative 7 and positive 6. Negative 15. So factors of 15 with a difference of 2. 5 and 3 pops into my head right away. It's a positive, so it's got to be positive 5. Subtract 3. This would be x plus 5 times x minus 3. You're going to be asked to solve some of these, and this goes back to the zero product property. We're going to be amping this up in another day or so, but on your homework you need a couple of story problems to do, or there's a couple of real life examples that we'll have to move some stuff around. So if I gave you something like this, and it said solve. Based on what we've done so far, you would be far-fetched to solve this. But this is where factoring comes in and where zero product property comes in. If I have this trinomial and I can factor it and set it equal to 0, I can find the roots or the solutions or the x's where this crosses the x-axis by letting y equal 0. First thing you need to do is set this equal to 0 by subtracting 30 from both sides. This now becomes x squared plus 7x subtract 30 is equal to 0. Now I know how to solve this because I can factor this and then use my zero product property. Here is where this is negative c, so I know it's going to factor if it factors. I'm going to try to factor it. We'll get into that. All of these will be factorable starting out. One is going to be plus, one is going to be minus. Factors of 30 with a difference of 7. Well, I got 1 and 30. That's too big. That's a difference of 29. 2 and 15, difference of 13. 3 and 10. There's my difference of 7. The 7 is positive, which means 10 has to be positive. It's my bigger number. You notice your b, your term here, is always going to have the sign of your bigger number because it's a difference. So this is 10 subtract 3 gives me a positive 7. 10 has to be positive. 7 has to be the minus. Or I'm sorry, not 7. 3. Now I can solve this. Remember, zero product property says one of these has to be 0 because this is a product and my product is 0. This would have to be 0 or this would have to be 0. So I can set up x plus 10 is equal to 0, and hopefully you remember these. X could be negative 10, or x minus 3 is equal to 0. I would add 3 to both sides. X is equal to 3. And I have 2 potential solutions for that. So we can't lose sight where we're going and why we're factoring. But that will get you started on your 7.5 practice A and B.